In this lesson, you will learn what a pure substance is and how it differs from mixtures in the field of chemistry. In our first lesson, we learned how to describe matter. We indicated that there are two different ways that matter can exist, either as a pure substance or as an unpure substance. Another word for an unpure substance is a mixture, and there's two different kinds. There are heterogeneous mixtures, which are not uniform, and homogeneous mixtures, which are uniform. So what's a pure substance? Well, in chemistry, a pure substance can either be a compound or an element. What are the properties of elements and compounds? They both have a defined composition. That means that they're always made of the same kind of atoms in terms of an element, or the same kinds of atoms in terms of a compound. Elements and compounds cannot be separated using physical separation methods. In fact, the only way that they can change is through chemical reactions. And elements and compounds can be defined and identified by their very specific physical and chemical properties. Let's take a look at the pictures that are down at the bottom of the screen. First, we have the blue image of the circles are all the same, meaning that an element can be made of all of the same atoms that are not bonded together. The second picture, we have molecules. Notice that the molecules are green. They're all the same, so that's still called an element because we only have one type of atom. In the third picture, we have a compound. It's a compound because we have two or more different types of atoms that are chemically bonded together. And then in the final picture, we have a mixture because we have both elements, singular and diatomic, and compounds just physically put together. They're not bonded. That's the important part to recognize. Now that we know the difference between an element and a compound, it's important to focus on a special class of elements called the diatomics. A diatomic element is made of the same atom, but they're only found in groups of two. Never found in nature as separate atoms. The diatomic elements are very important to memorize. Use the mnemonic below. Have no fear of ice-cold beer, using the first letter of the elements that are found this way. It's important to remember because whenever anyone is referring to hydrogen, you have to remember that the formula is H2 and not just simply H. Likewise, if I tell you to write down the formula of nitrogen, you have to remember that nitrogen is written as N2 and not just simply N. Compounds are substances made of two or more atoms chemically bonded together. Do not leave chemically bonded out of your definition, because if you do, you might be defining a mixture accidentally. Compounds are defined by two different laws. The first one is the law of definite composition. This law says that a given compound always contains the same fixed ratio of elements. We can see that in the graphic. Water is always 1 oxygen to 2 hydrogens. Sodium chloride is always 1 to 1. Ammonia, always 1 to 4. The law of multiple proportions indicates that elements can combine in different ratios to form different compounds. And we can see that nitrogen and oxygen can combine in many different ways. Let's review what we've learned so far. Here's some examples. Graphite. Is graphite an element, a compound, or a mixture? Well, you may not know what graphite is, but graphite is pure carbon. And because it is pure carbon, graphite is an element. Pepper. When you look at pepper, you can see little white specks, little black specks. The components are very visible. Therefore, pepper is a heterogeneous mixture. When you look at sugar, sugar is a compound. It looks uniform, and we would have to chemically identify the fact that sugar is made of precise atoms in precise ratios. What is paint? Paint is a heterogeneous mixture. We know that it's a mixture because you have to stir it. It settles once it sits too long. And then finally, soda pop. Soda pop is a homogeneous mixture. Homogeneous mixtures can also be called solutions. We talked about physical properties. Now let's look at chemical properties. A chemical property is any property that can only be observed when a chemical reaction is taking place. The chemical property will always form a new substance, and the new substance will have a new set of both physical and chemical properties. In the image here, we've got CH4 with its methane gas, plus oxygen will have a reaction creating carbon dioxide and water. The properties of flammability only exist when a chemical reaction of flame takes place. So again, a chemical property is only observable with your five senses. So seeing, smelling it, tasting it, etc. is only observable during a chemical reaction. And here are some examples of different types of chemical properties. Toxicity. Chemicals can only kill you if a chemical reaction of ingestion and digestion is taking place. Because chemical properties only are observable when a chemical change or a chemical reaction is taking place, we should know the signs that a chemical reaction is taking place. The only sure way to know if there has been a chemical change is to identify the new substances, how the atoms have changed. But sometimes that's hard to know, so we need to look for certain clues. The first sign is odor production. We're talking a new odor, not just something having an odor, but a change in odor. Second sign, change in temperature. Exothermic reactions are occurring when energy is released, for example, wood burning. A change in temperature can also mean a reduction in temperature, as in a cold pack. A change in color. We can see this with the fall foliage or when you dye your hair. The formation of bubbles indicates the presence of a gas. We saw this when we did our canister and we made carbon dioxide and it caused the top to pop off. The formation of a precipitate. This is an important chemical word. Precipitate is a solid substance that forms between two liquids when two liquids are mixed. The solid is precipitating out of the liquids. There are some other properties that we have to consider when we talk about chemistry. Extensive properties are properties that change when the amount of matter in the sample changes, and we've got some examples like size. The property of size changes when the amount of matter changes. That's pretty simple. The most important one, or one of the most important ones, is energy. Think about a cup of coffee. How quickly will coffee cool down? It's going to cool down a lot faster than a bathtub full of water because there's more matter. So energy is also an extensive property. And now we have intensive property. An intensive property is a property that does not change when the amount of matter changes. For example, the color doesn't change when you cut a piece of paper into a smaller piece. Boiling point of water is always 212 degrees Fahrenheit. Physical and chemical properties can be either extensive or intensive. And that is the end. Great job.